be also about 5:30-ish, just like I have in the previous exams. They were designed to take 75 minutes, but I will give you 90 minutes or so if you would like it. So of course, in terms of things to bring a calculator. This is the one exam where you should definitely bring a calculator because the computation is a little more intense than just addition and multiplication. Bring a calculator. Scantron, same as the previous two exams. Number 2 pencil, pen, highlighter, the other basic test taking tools. Formula sheets, as indicated, will be provided, as will the Z-table. Same Z-table that we have been using. Good idea to familiarize yourself with the formula sheet minus inventory management, of course. And making sure you're comfortable using the Z-table. Format. Oh, so same idea, it's multiple choice and free response. The number of multiple choice on this exam is 20. 20 multiple choice. There are fewer multiple choice. What do you think that means? There are 4 free response. All right. Let's talk about what to expect on the free response. All right. One of the problems will be a market share analysis. So very similar to problem set 8. You'll have information about the initial market shares. You'll have information about the customer loyalty figures, transition probabilities, and all that. Based on that, figure out the market shares in a subsequent period, and then figure out the equilibrium or steady state market shares. So of course, if we think about what we talked about when we did the lecture on market share analysis, since I'm asking you to find the steady state, that should tell you that the market share analysis on the free response will be the 2x2 case. It will be a 2-firm scenario. Again, similar to problem set 8, if we look at number 4 on the practice problems, that's also a good one to look at. It's very similar to the example, the 2-state market share analysis, 2-firm market share analysis, and the problem set problems. So you're given information about the initial market shares, and you're given information about the customer loyalty figures. Based on that, determine the market shares for the next quarter, and then determine the equilibrium / steady state. You're given the initial market shares, that's pi 0. You're given the transition probabilities, that is the transition probability times P. And for market share analysis, the 2 formulas that you need. You're given the market shares in one time period, and you multiply them by P, it'll give you the market shares in the next time period. So be comfortable with matrix multiplication there. And then remember, when we're finding the steady state, we are trying to find a vector pi such that when you multiply it by the transition probability matrix P, you get the same state vector. So of course, there's the algebraic process for that. Of course, there's a shortcut as well. If you use the shortcut, make sure you use it correctly, because you are allowed to do that. All right. So of course, this will be a 2-state problem. Of course, anything involving 3 states, A, I would never ask you for the steady state, and B, it would be on the multiple choice. It would be a fairly straightforward question, so some sort of conceptual stuff about market share analysis. The free response, it'll be, it says, finding pi 1 and then finding the steady state.
Are we going to deal with absorbing states?
So for the market share analysis, no. No. But of course, for accounts receivable analysis, we will talk about that. Yes. Yes. All right. Any questions on market share analysis? Anyone? Okay. Next, I will give you a question on matrix operations. So we used a lot of matrix operations here, matrix multiplication and matrix inverses. So I want to make sure you are comfortable with those, yeah.
This is free response?
Yes, yeah, this will be the second free response. Second that I talked about, in no particular order, second free response is matrix operations. So if you recall, we talked about matrix multiplication, but of course, I'm already assessing you on matrix multiplication when we do market share analysis, and also in theory, accounts receivable analysis. So chances are this will involve something fairly straightforward, as in I will give you a matrix, you'll have to find its inverse. That's pretty straightforward. So again, if I give you a square matrix, find its inverse, you find its determinant, and then you take 1 over the determinant and multiply it by its additive, that structure right there. So of course, all that information on this formula sheet will be given to you. You literally have to just plug in and find the inverse.
And that's sufficient enough to get the right answer?
Yeah?
Like
Yeah.
no tricks?
Yeah. And of course, this is a scenario where it will have an inverse. So remember, there are some square matrices that don't have an inverse. But of course, this one will have an inverse. For the record, actually, let me use that one on the computer, sorry. So for the record, when does a square matrix not have an inverse?
When the equals 0.
Well, the determinant equals 0. So A inverse does not exist, so remember that. If the determinant of A equals 0. So of course, the problem I give you, it's something that I want you to be able to solve. It would be really ridiculous of me to give you a problem that has no inverse. So the determinant will clearly be non-zero. So it will be invertible. And of course, what do you call it if you can't find the inverse? What's that kind of matrix called?
No idea. Oh, singular.
Singular. You know, I love those conceptual questions on multiple choice.
Yes.
Generally, if you look through the notes and there's a word in bold, it's probably worth knowing. I try to make it really obvious, in case you haven't figured it out. Now is a good time. Yeah. So of course, if I give you a matrix, finding its inverse, should be able to do that. Just plug into the inverse formula. And of course, it will be a 2x2 matrix. We didn't talk about finding higher order inverses. In theory, I can also ask you, I like how I frame all these as hypothetically in theory. In theory, I can also ask you to verify that what you got for the inverse truly is the inverse. So when you want to verify something mathematically, what can you do? The correct answer is not do it again. What do we know about inverses? If I have the, what does it mean for a matrix to be an inverse of another matrix? Again?
Opposite of that.
Well, what do you mean?
Like if you graphed it, one would be up.
Not quite. I'm talking about matrices. It doesn't
So
really.
you're diagonally flipping them. So like in that example, like A11 in the top left will go to the bottom right.
Right, right.
And then the top right and bottom left become negative.
Right, right. So that's how you find the inverse, right?
Yeah.
But when you find the inverse, what do you find? What is the definition of an inverse? For a matrix, if I have an inverse, if the definition is such that if I take the original matrix and I multiply it by its inverse, order doesn't matter, what do I get?
You get 1.
Well, I get the matrix version of one, the identity
Oh.
matrix, right?
Yeah, I remember that.
So you want to verify that the inverse truly is the inverse, you can just multiply it by the original matrix and make sure you get the identity matrix.
Is there like an example real quick?
Sure. All right. Number 6. According to this, A is 2, -4, 1, All right, 2, -4, 1, -2. So we want to find its inverse. What's the first thing we have to do? We have to find its. I'm not going to say it. I'm going to wait for y'all. Determinant. I already know how to do this, I'm making sure y'all do it. All right, find its determinant. So of course, remember the determinant A11 times A22 is the product of the main diagonal. So 2 times -2 minus the product of the off diagonal. -4 times 1. All right, -2 times negative, sorry, 2 times -2 is -4 minus -4. All right. In that case, does the inverse exist?
No.
No. And you can easily tell that in this case because if you take the first column and you multiply it by -2, you get the second column. So these columns are not independent. So let's do a better example, a more useful example. Let's do B. Let's make that 4 that's in the upper right corner positive. All right. Now let's find the determinant of B. So it's going to be main diagonal minus off diagonal. 4 minus 4, which is
-8.
negative. So in this case, the determinant is non-zero. So that means the inverse does exist, right? All right. So of course, let's find B inverse now, rather. So B inverse. So remember, it's 1 over the determinant times this adjugate matrix. All right. So main diagonal A11 and A22, or in this case B11 and B22, switch positions. So in this case, it's kind of a bad example because it's 2 and -2. So remember, they're switching positions, they're not changing signs. So 2 and -2 are swapping places. So this is -2 now, this is 2. And then the elements on the off diagonal are going to simply change signs. 4 becomes -4, 1 becomes -1. All right. So if we distribute that -1/8 in there, -2 over -8 is 1/4. -4 over -8 is 1/2. -1 over -8 is 1/8. 2 over -8 is -1. And of course, if it's a nice determinant like that, it's an integer determinant, you can leave it as fractions, that's totally fine. And remember, like I said before, if you don't reduce those fractions, that's okay too. So if you were to leave this as 2/8, that would be fine. I'd be okay with that.
So you'd be okay with 0.25, 0.5?
Exactly, yeah, so decimal form is fine also,
Okay,
yeah,
okay.
yeah.
So if it's in decimal, would it matter like how many like digits we round up to, or?
I think I specify on the exam at least 3, yeah. So in this case, 1/8 is 0.125, so 3 decimal places is more than that. Yeah, I think I specified 3 decimal places. All right, how can we prove that this is the inverse? Or verify, rather.
Multiply it by the 2, 4, yeah.
Yeah, exactly, multiply it by the original matrix, yeah. And again, the order doesn't matter. It could be B times B inverse or B inverse times B. Either way, you should get the identity matrix. All right, so B is 2, 4, 1, -2. And then we have 4th, half, 8. Okay. All right. Remember your matrix multiplication. First row, first column. Times 1/4 is 4 times 1/8. First row, second column. 2 times 1/2 equals 4 times -1/4. Second row, first column. 1 times 1/4 plus -2 times 1/8. Second row, second column. 1 times 1/2 is
-2 times -1.
All right. Half plus a half is 1. 1 minus 1 is 0. 1/4 minus 1/4 is 0. Half plus a half. Verifying that is the inverse by multiplying b times b
Are we gonna have to do that on the test?
Possibly.
Okay.
Yeah.
Check our work.
Yeah, exactly, yeah. So when I say verify, you're basically checking your work, yeah. So using the properties of inverses, you're showing that, okay, if I take the original matrix and I multiply it by its inverse, it gives me the identity matrix. Of course, if your inverse is wrong, then here you should not get 1, 0, 0, 1. So that would be a good way to go back and check, oh, I need to make sure I did this multiplication correctly. I did this inverse correctly, or I did this multiplication correctly. If you get the wrong inverse, but somehow miraculously end up with 1, 0, 0, 1, and when you multiply them together, I will know you did not actually multiply them together. Like, after grading 70 of the same exam, I can tell if it's correct or not. So it's like, did you actually do the work or not? I can figure it out. So, is that the only way to verify that it's the inverse?
Probably not.
Probably not. If I'm asking, it's probably not. Good answer. All right. Don't forget, the inverse is an operation that undoes itself. So if you take the inverse again, you would end up back where you started.
So could we just do that?
You could do that. Either one would be accepted. Yeah. Either one uses the properties of inverses to verify it, so that would be fine too. Absolutely. So like I said, be comfortable with matrix multiplication, be comfortable with matrix inverses. So of course on the practice problems, number 6, we just did that one. So of course we know why A inverse doesn't exist in this case. A is singular and its inverse does not exist. There we go. And here we got B inverse. Like I said, to verify the inverse, you can multiply by B by B inverse, you get the identity matrix, or you can take the inverse again. Either one is fine.
Just make it, I just verified, yeah.
Cool.
It's-
I would say this one might be a little more complex because, well, not complex, it's just you probably have to deal with more ugly fractions. So, I mean, here it's multiplying fractions, and here it's going to be dividing by fractions. So, of course, if you feel like you need more practice on that, don't forget I have the matrix operations practice problems. Matrix multiplication up here. Matrix multiplication, find the inverses. Here's another Markov problem right there. Here's an inverse. 3-state Markov process, just multiplication. Remember, like I said, you're not going to have to find a steady state for a 3-state process. Show that B is singular. Is this the exact same one? Like, is that, it's like sometimes my, my propensity to recycle things, 2, 1, 4, -2. Oh, it's just, okay, it's not, okay. -2, 1, 4. Interesting, yeah, wow. That one's also singular. Because if you take the right column and you multiply it by -2, you get the left column. All right, A matrices. Any questions on that? Any more questions? Okay. So of course, that brings up the third one, which is accounts receivable analysis. So remember the whole process for accounts receivable analysis. If you look at the sample problem here, you're given the accounts receivable matrix. Look at what we do. We split it up into these block matrices. And of course, the structure of the blocks will be given to you on the formula sheet. So take that 4x4 matrix, you split it into these 4 2x2 matrices. Yeah. Yes, yeah, this is the third free response. So, the accounts receivable analysis. So taking your matrix and blocking it. So up here you have an identity matrix, you have a zero matrix, what we call Q, and what we call R. So of course we call that, the matrix will always be in the structure. I'm not going to trick you. It will always be where you have paid off and written off as bad debt as the first two states, good standing and delinquent as the other two states. So in that order. So then based on that, you have the process of finding the steady state, the equilibrium. So what in the long run, what proportion of good standing debt and delinquent debt will both be written off, or paid off and written off. So remember, we have this process for that. Look at the example, it goes through the entire process. So compute N, call the fundamental matrix. So we call how we find N, it's I minus Q inverse. Of course, I think I already told you that I'm going to give you a problem where you have to find the inverse of the matrix, right? Is it really worth it for me to test you on that again? If you know how to do it once, you know how to do it the second time, right?
Duh.
If you don't know how to do it, you don't know how to do it the second time either. So I guess it kind of works both ways. So yeah. So chances are this accounts receivable analysis won't be a full accounts receivable analysis, in that I may have done the first part for you and maybe given to you. I might have already computed I minus Q and taken its inverse. Well, in that case, all you have left to do is, well, N times R will give me the probability matrix for that, proportions of debts that will be paid off and written off. And then if I have the amounts, I can compute the amounts that will be paid off, amounts that will be written off. So essentially, if you think about it, if you consider problem set number 9, I believe. I'm basically following this process for problem set 9, but of course, everything up to part D will have been done for you. Really, all you have to do is part C and F. But the key is you have to be able to recognize that everything up to that point has been done for you. So, if I give you N and R, what are you going to do with them? Say again? Multiply them. Multiply them together. But will I necessarily tell you that you should multiply them together?
Well,
No.
the formula chart, you do it, right?
Well,
I mean, if you have,
Technically,
if you have
right?
N and you have R.
if you have N and R, what the hell else are you going to do with them?
Exactly.
I'm giving you two 2x2 matrices. What else can you do with them? So chances are this problem will be worded as compute the estimated proportions of good standing. It won't tell you it's NR, but it is NR. Same idea here. Using your result from the previous part, compute the estimated amounts that we paid off and written off. So you'll have to know how to apply the matrix multiplication in context.
So you're not gonna have the in art on the test.
So I won't tell you that it's N times R. You will have to know that it is N times R.
So you're just gonna give us N.
And R, figure out what to do with it. And I think I just told you what to do with them.
Here's N, here's
Yeah.
R, do something.
Exactly. Yeah. What did I do with them? Yeah. Yeah. I mentioned I tell you exactly what's on the exam.
Yes.
All right.
I would hope so.
Yeah. So basically, it's going to be just the final part of accounts receivable analysis. Again, as long as you find NR and then you find V times NR, it might ask you to interpret something, but that's really about it. That's really all I can do. And by the way, make sure your answers make sense. If you find N times R, make sure everything in the matrix is a valid probability. Like if you get values that are more than 1 or negative, you probably did something wrong. Always double check that. Yeah. Make sure your answer makes sense. I'm not gonna lie, when I write this exam, I sometimes put a lot of, well, especially on the multiple choice, like, I mean, well, some of the answers are, you know, designed to be like, well, if you kind of know what you're doing, but not quite, you might pick this answer. Some of them are like, why would you even choose this answer? Like, if I tell you, for example, calculate this probability, and one of the answer choices is 1.7, please don't pick that one, because a probability has to be between 0 and 1. So, I will say that, okay, just make sure you don't pick an answer that's silly. That's kind of the point. Silly is the nice one. So. Okay. So that's all you'll have to do for accounts receivable analysis. On the free response. Obviously some more conceptual stuff, other things, like I will ask you that on the multiple choice. All right, any other questions on accounts receivable? All right. So that means the last free response will be something related to queuing theory. Of course, when we did queuing theory, waiting line models, there were a couple things we talked about. So when we did, the first thing we did was we talked about the probability distribution for the arrival process and the service process. So remember, the arrival process follows a Poisson distribution. Lambda is your average rate of arrival. And then the service process follows an exponential distribution, and your parameter mu is your average service time. So computing arrival probability is the probability of a certain number of customers arriving in a certain period. That'll follow the Poisson distribution. You use the mass function for the Poisson distribution, which is given to you right here. So Poisson distribution is probability mass function. Plug in, compute those probabilities. If I ask you for the probability that service takes a certain amount of time or less, then you use the exponential distribution for that. But of course, then we also talked about those 6 service characteristics. So recall that they're given to you in, well, let's actually look at the queuing theory here. They're given to you on page 1 of the lecture on queuing models. So again, these are all characteristics of the queuing system. So they're functions of both the arrival process and the service process. And recall we have these 6 equations in the same order for those 6 characteristics. Those 6 equations are given to you on the formula sheets. So of course, remember number 1, they will not be labeled on the formula sheet. What you see is what you get. But of course, the left-hand sides will be there, so you can figure out based on that which formula corresponds to which. So P0 is the probability of 0, the probability that no units are in the system. So that means there's no one in line, there's no one currently being served. LQ, the average number of units in the queue. So how many people are waiting in line? L without any qualifiers, just how many people are waiting and being served. So how many people are in the system. So that includes the line itself and the service window. Yes?
For the Poisson, what is the symbol called again?
Mu.
Oh, for the Poisson, it's lambda. Yeah.
Lambda.
Lambda for the Poisson, and then mu for the exponential. Yeah. And of course, remember, all these formulas are going to be functions of both lambda and mu, because they relate to both the arrival process and the service process. So the number of people waiting in line, well, that depends on not only how frequently people are arriving, but also how frequently people are being, taken care of at the end of the line. So all these operating characteristics have both lambda and mu. A couple of notes, very important. Lambda and mu, which one has to be larger?
Lambda.
You.
Oh, mu is divided here, right there you go.
If you're not sure, think about it logically. If lambda is larger, what happens to this denominator?
It's gonna be a negative.
It's going to be negative, which doesn't make sense for the number of people. So mu has to be more than lambda. So your service rate has to be more than your arrival rate. Because otherwise, logically, your line just keeps getting infinitely long. So mu has to be more than lambda. Obviously, on the question I give you, since I'm asking you to compute some things, mu will have to be more than lambda. Otherwise, it'll be completely bogus.
So Target can't use this one.
Yeah. So obviously, I'm just like, the other problems, I will have to give you something that's worth solving. So. All right, make sure of that. Make sure we're okay with that. We've already done this. All right, in this case, we are told that on average 51 customers arrive per hour, and the average service time per customer is 48 seconds. So if we want the arrival rate lambda in customers per minute, what do we do?
51 divided by 60?
51 over 60.
60 seconds, right?
Exactly, yeah. So it's given in customers per hour. If we divide it by 60, it'll give us customers per minute. The conversions I will ask of you will not be very complex. I hope that we are at the point, we are all at the point in our lives where we know that there are 60 minutes in an hour, or 60 seconds in a minute. I would hope we're okay with that. So, 51 over 60 is 0.85, I believe. All right, remember lambda is the arrival rate. If you conflate lambda and mu, just keep in mind the logical thing that I just told you. Lambda always has to be less than mu. All right, average service rate in customers per minute. So the average service time per customer is 48 seconds. So if I want that to be customers per minute, what do I do? 60 divided by 48. Good. So it's time per so it's one customer every 48 seconds. If I multiply it by 60, that gives me customers per minute. And again, helpful to think about whether this value is
Oh, I
logical.
did that backwards, Professor.
Uh-oh.
You know, but it's things.
What did you do?
I did 48 divided by 60.
Ah, but
And
if
then
you
I
do
did
that, you
one-
get 0.8, right?
1 point divided by 0.8.
They-
I did 1 divided by 0.8
Oh, that'll work too, yeah.
after that.
Yeah, that'll work, yeah.
Okay.
Yeah, that would definitely work, yeah.
Okay.
It's all multiplication, yeah.
Yeah.
So if you divide by 60 and then take the reciprocal, it's
Yeah,
the same thing.
yeah.
So again, logically, make sure that your lambda and mu makes sense. Like in this case, okay. If they're fairly close together and mu is a little bit larger than lambda, then that means you probably did it correctly. Like, I'm not going to give you a scenario, by the way, where lambda is like 0.02 and mu is like 30. That just wouldn't make sense. So I was like, well, what's the probability that no one's in the system? Like 99%. So very unpopular business. So. Okay. Other thing to note on this. So we have two kinds of things. We have arrival probabilities and service time probabilities, and then we have the operating characteristics. If you remember nothing else, well, I hope you remember more than just what I'm about to tell you. On the free response, I will only ask you about operating characteristics. What does that mean? The only formulas you will need for the free response are these 6 operating characteristics formulas.
And will we be using all 6?
Potentially.
This is for the free response.
Is that okay?
Yes. So on the free response, I will only ask you about the operating characteristics of whatever system I described to you. Meaning I will not ask about arrival probabilities, I will not ask about service time probabilities. Where will I probably ask about those? In the multiple choice. I have to assess you on
don't have to.
Oh yeah, I do. I need to. I feel like it's only fair that
It's a choice.
I taught it to you. I want to make sure you learn it. So, again, that tells you that on the free response, if you are here today, you should not use the Poisson distribution or the exponential distribution. Those will only be used on the multiple choice. Conversely, I will only ask you about arrival probabilities and service time probabilities in the multiple choice. I will not ask you about the operating characteristics. Those two things are, as we like to say, mutually exclusive. Multiple choice probabilities, free response, operating characteristics. Keep in mind that one of the operating characteristics, well, two of them technically, is the probabilities of either 0 or n units in the system. So they are probabilities, but they are operating characteristics. They're not arrival probabilities, they're not service time probabilities. They're functions of both. So if I were to ask you about a probability on the free response, it would be one of these probability formulas. Using problem set 11 as an example. The probability that the service window completes a customer's order within a certain amount of time. What formula am I going to use? Exponential. The probability that the number of arrivals in a 1 minute period is something. Which formula would I use for that? What's on this? Not operating characteristic, not operating characteristic. Because it's just about service times, just about arrivals. All right. Everything else, therefore, has to be an operating characteristic. Probability that an arriving customer will have to wait for service. Of these formulas, which one am I going to use? So P0 would give me the probability that they don't have to wait for service, because that means nobody's there. So if I want the probability that they will have to wait for service, I take P0 and do what? Exactly. Take its complement. 1 minus P0. All right. Average amount of time that a customer spends waiting in line before they reach the service window. Which of these characteristics is that? WQ. Time they spend waiting, waiting time in the line in the queue is WQ. Average number of customers waiting in line. LQ. Average amount of time the customer spends in the entire system from getting in line to receiving their sandwich. Just W. Average number of customers in the service system. L. And the probability that there are exactly 2 customers in the service system. So use the PN formula and N would equal 2. Exactly. Good. So be able to pick out which formula you need based on that. So of course you're probably wondering, why don't I just label? That I'm really not testing you on anything. It's literally just plug in and go. It's like, oh, the probability that no customers in the system. Let me use the formula that there are no customers in the system. So seems kind of all right, so that is the free response. We have market share analysis, matrix operations, accounts receivable analysis, only part of it, the latter part of it, and then the operating characteristics for the
Question, Professor.
yes, David.
So if, let's say, you're waiting, it's asking you when, what's the probability that you don't have to wait, correct?
Don't have to wait. So if
That
you
would
don't
be-
have, that would just be P0.
Okay.
Yes, yeah. Because that means there are no customers in the system. So that
Okay,
would be P0.
so we just gotta watch that, 'cause
Right,
you might
yeah,
switch
yeah,
it up,
yeah.
yeah.
So will not have to wait would be P0.
Okay. We'll have to wait.
Will have to wait is it might be. All right. Any other questions on the free response? Alright. So again, talking about the multiple choice again, it's just like the previous multiple choices. Again, understanding some of the terminology is always helpful. The big thing on the multiple choices, you'll notice that PERT is not in the agreed response, which of course means it will be restricted to multiple choice. But of course, you'll have to do essentially what you did for problem set 10. Be able to do all of these things. So, if I give you a table like this, be able to compute the mean and variance of the activities. Obviously, I'm not going to ask you for doing the entire thing. I might give you the same one and be like, oh, tell me the expected time for activity C. Tell me the variance of activity E, something like that. And then, hypothetically, if I give you a network and I give you all of the expected times, you should be able to find the critical path. It's just the longest path.
Is the formula for these gonna be on the test?
Yes.
Okay.
So for these,
Yeah.
look at the top of page 1 of the formula sheet. So we have, the formula for the expected time for each activity, and we have the variance for the activity duration. We have those two formulas given, so similar to part B. And then remember, the expected project duration is just the duration along the critical path, using the expected times.
We're not gonna have to draw an arrow.
No.
No, okay.
It may help you if
To
there's
do
a
it.
question related to that on the multiple choice, but you will not have it.
Understood.
So find the critical path by finding the longest path using the expected times as your durations. And then the variances, once you find the critical path, just add up the variances on the critical path to get the variance of the project. All right. And of course, then you have using the normal distribution to compute probabilities. All right. Over here, say we were doing problem set 10. All right. Hypothetically, we're doing problem set 10. Just want to make sure we're okay with these probabilities. So hypothetically, let's say we have the critical path, we have the mean, and the variance, take the square root to get the standard deviation. Now we would compute probabilities, right? All right, part D. The probability the planning process is completed within 13.9 weeks. Oh, what would you do with that 13.9 weeks? You plug it
Minus ET? Or-
yeah, so you plug it into the z-score formula, right?
Yeah.
We want the probability that time is less than 13.9 weeks. Remember, within means less than or equal to 13.9. 75. Remember, it's divided by the standard deviation, not the variance. Oh, wait, I have the answers. That's C. So to compute that z-score, you get like 0.5.
Yes, it's 0.5.
0.5? All right. So I want the probability that Z is less than 0.50. What would I do? I would look up a Z-score of 0.5 on the Z table, right?
Yeah.
If I do that, with a Z-score of 0.5,
It's
which-
0.6915.
0.6915.
Pretty sure.
Yeah, I'm pretty sure.
No, I think.
Yeah.
Question, is that my answer?
No.
No.
You gotta put it.
I kind of just instinctively said no, like I'm trying to trick you. Remember, what does the table give you? It gives you the probability to the left of whatever z-score you look up.
You gotta move your decimal over. Cause it says a probability, so it's 69.15%.
You don't have to leave it, you can
No,
convert it
take
into a
one-
percentage if you want.
You take one, you subtract it, right? One.
What does the table give us?
No.
It gives us the probability to the left
Which
of
is-
whatever z-score we look up. Did we look up a z-score of positive 0.5?
Yes.
So is the probability we got the answer to this problem?
Yeah.
Makes sense, because that probability should be more than a half. What about part E? The probability the process takes longer than 12.4 weeks.
Oh.
First thing I would do is
Yeah,
find
me
what?
too.
We checked it together.
The
Yeah.
z-score.
I didn't, yeah, I thought you still had subtracted one.
What's my advice always been?
Or no, not subtract one, but one minus the 6.9.
What is my advice
So it
always?
should make sense that that number.
If it doesn't confuse you. So you want to make sure that this sign is less than or equal to. You want to make sure this z-score is positive, because that's what the table gives you.
So that's why it's- no, this is like-
Also, what's the advice I always give you?
Double check your work.
What?
Double check your work.
What's the advice I always give you?
Draw, shade it out.
Draw it. Shade the area that you're trying to find the probability for. You know that the normal distribution is symmetric. So I want to find the probability to the left of the z-score of 0.5. 0.5 is obviously more than 0. That's a 0, not a lowercase cursive delta. Is that probability more than a half or less than a half?
Less. Oh, 12.4 is less.
No, sorry, I'm sorry, for part D, excuse me. Is this probability more than a half or less than a half?
More than.
More than a half. That means whatever you look up has to be your answer. Let's do this. Let's find the z-score for this. 12.4 minus, my mean was 13.375 divided by the standard deviation. If I do that, I get a z-score of negative 0.92.
Just take the inverse.
All right, so what would I do in this case? I'd look up a z-score of
0.92.
positive 0.92, which if I do that, I get
That's it.
the probability associated with a z-score of positive 0.92 is 0.8212. 8212. What do I want to do with that probability?
You're gonna subtract it from 1.
Are you sure?
Yes. Because it's not like, if you're time, and just by logically speaking, 12 weeks is less than 13 weeks.
Okay,
If 13 is your 50%.
right. My z-score is negative,
You
but
can't
what
have an
area?
82% probability of finishing less than
What's my probability? What am I trying to find though? The probability that it takes
12 weeks,
or
or more. Oh, yeah, okay.
is that probability more than a half or less than a half?
It's more than, so it's there. I didn't look at the sign.
Ah. Because remember, when you take the complement, what are you doing? You're fixing if the sign is wrong, or sorry, if the direction of the inequality is wrong, or if the sign of the z-score is wrong. So if your z-score, if your inequality was greater than, or if your z-score were negative, you'd be fixing that problem. But in this case, which of those two things is wrong? Both of them. Which means technically you have to do what? Take the complement twice. If you take something and you subtract it from 1, but then you take the answer and you subtract that from 1, what do you get?
Same thing.
The same thing. If I take 0.8212 and I subtract it from 1 to change the direction of this inequality to less than, but then I take the complement again to change the sign of the z-score to positive, 1 minus that cancels out. So mathematically, it works. Graphically, it works. This is all stuff you should have learned in stat, which you probably did if I taught you. I'm kidding.
Or if you took stat one somewhat recently,
At least it only has one
total
table.
post-COVID.
Yes, yes.
Well, thank you, Professor.
Yes, yeah.
Because I definitely
Now you
made a
can go
mistake.
back and pass that one too, really.
It's like you knew we were gonna miss that one.
No, yeah, no, of course, yeah. I see things. You know, when I'm pre-grading, when you're asking me questions via email during office, I remember things. I want to make sure to go through these. Because you know, when you write multiple choice tests, if I were to take the complement of 0.8212, what's that? 1 minus that is 0.1788. If I were to ask you this problem on the multiple choice section, and the correct answer was 0.8212, well, what is the probability that 0.1788 would also be an answer choice?
That's just cool.
Very high.
It's almost surely. That's 1. It's not cruel. I just got to figure out you know what you're doing. That's the good and bad thing about, you know, what do we call it?
So the
Multiple choice.
The 17.888 is not the answer?
No.
No.
No, no. Remember, because we took the complement,
Yeah.
but then we took the complement again.
Okay.
So yeah. It's my biggest piece of advice. Sketch the graph.
Good thing we gotta pay attention to signs like always.
Yep, exactly. Sketch the graph.
Sure, son.
And we are at the point where we should know that the alligator eats the bigger number. This means greater than, this means less than. We're at the point where we should know that.
Can you draw the teeth in there for me?
On the teeth. Yeah, there you go, all right. There you go, yeah, there you go. Got the little snoot. Yeah. There you go. So definitely, just make sure, your sign is correct. Make sure it's logical, yeah. All right. So of course, with PERT, be able to do that. And of course, part F. What do you have to do in part F? You're doing the same thing except what?
You gotta, you're given the percentage, so you kind of.
You have to solve for T.
backwards.
Exactly. So you're given the percentile. So you find the z-score for that on the table, and then you find the value for t for that. And that answers, yeah. Okay, good. All right. And again, just look over the, kind of the, like I said, if something's in bold, just kind of know what it is. That's generally a good piece of advice. Like, know what a stochastic process is. One that's time dependent, which is random. Know what a Markov process is. It operates sequentially, transitioning from one state to another within an allowed set of states. Just know the terms that are bold. If I want to multiply matrices, they have to be conformable. Number of columns in the left matrix has to equal the number of rows in the right matrix. Know how to compute matrix products. Know these elements of a Markov process. If I want to fully define a Markov process, I have to know the states, I have to know the initial state, and I have to know the transition probabilities. There's 3 things for a Markov process. Understand the structure of the state vector and the transition probability. You might have to interpret some probabilities. Again, accounts receivable analysis, we talked about all that. So inverses. What an inverse is. We talked about the definition of it. Because we want to be able to prove that something is an inverse. What an identity matrix is. What a singular matrix is. One you can't take the inverse of. And of course, for accounts receivable analysis. What's an absorbing state?
State, once you enter it, that will never change.
Exactly. So once you enter the state, you cannot exit it. So for our purposes, in the context we've been using it, the debt being paid off, the debt being written off as bad debt. So any dollar that's written off, any dollar that's paid off remains paid off or written off in perpetuity. So this matrix, the probability of going from paid off to paid off is a 1. Kind of defines the structure of this matrix for us. So that tells us these are absorbing states. And like I said, just recall the process. Find the inverse of n, or that's the fundamental matrix. And then you compute NR and you compute ER, even if you're not explicitly told that that's what you need to compute. If I give you N and I give you R, that's probably what you're going to do. All right. Talked about PERT, talked about queuing. That's really about it. In terms of the practice problems, just looking through those real quick. So recall number 1 is about inventory management. You can omit that. Number 2 is an accounts receivable problem, so make sure you're able to replicate that. And of course, remember when I said that, when I give you the question, it might not say compute NR to determine the proportion. It might just say determine the proportions. I might make the object of that prepositional phrase the subject of the sentence. All right. 3 is a queuing model. For the record on this one, passengers arrive at the checkpoint at a rate of 1.8 customers per minute. So that's the arrival rate.
That's already the mu, right?
Arrival rate is which one?
Oh, lambda.
Lambda,
Sorry,
right,
sorry.
yeah. So if we want mu, remember that's the service rate. The TSA agent can screen 1 passenger every 24 seconds.
So it's 60 divided by 20?
60 divided by 24, good, which is 2.5. So that works because, remember, we want to make sure our mu is more than our lambda. Otherwise the line gets backed up, like at O'Hare. And it's a small airport, that's why there's only 1 line like this. So make sure mu is more than that. And of course, remember, for those operating characteristics to work, mu and lambda have to be in the same units. That's important. And remember, when you compute the probabilities for the service process. So here it's asking for the probability the screening time for a passenger is less than 15 seconds. Well, we said mu was 2.5 passengers per minute. So in that case, what do you have to do to compute the probability that the time is less than 15 seconds? What would you have to do?
Convert everything to seconds.
Exactly. So you can either convert mu into seconds, or your customers per second, you could do that and leave the 15 in seconds.
Or convert
Or
seconds to minutes.
convert the seconds to minutes, which probably is easier because you're dealing with fewer fractions. And your mu is probably in a form that you want it to be in for the rest of the problem. Good.
Point, wait,
You would go 15 divided
0.8? Oh, yeah.
My answer is correct too. Yeah, so convert that to minutes. So 15 seconds is 0.25 minutes, and then you just plug into the CDF of the exponential distribution. So I'm remembering last semester when somebody told me when I was going over the exam 3 review, they were like, wow, I was 2 years old when I learned that you gave us the answers to these. Yes, the whole point of the practice problems is that I give you the answers. All right. Yeah, oh, all right.
Well, Trey, yeah, you would get a lot more questions from students, right? Bothering you, yeah.
It's like, well, that's what you work on, so you know if you're correct or not, yeah. All right, number 7 is another queuing problem. All right. And number 8 is a PERT problem, they're worthwhile to look at. And of course, remember number 9 and 10 we can omit because they are inventory management. But I left those in there in case you are curious about inventory management, some of you probably are. I left those in there. Along with their answers. Alright, so all the solutions are there. Two is there. Alright. What other questions do you have? Alright. So of course, this is the point where I give back your exam. And this is the point where I remind you once again on Thursday, please.